Alright, what's up guys? In this video we're going to pick up with some differential equations. We're going to be talking about second order linear homogeneous ordinary differential equation. So we're asked to solve or find the general solution to the second order linear homogeneous ODE. So we're given y double prime minus 6y prime plus 13y is equal to 0. So remember, we can always tell whether or not the second order equation is homogeneous or not. If it's equal to 0, it's homogeneous. If it's equal to some non-zero function g of x, it is non-homogeneous. Now remember, the form for a second order linear homogeneous differential equation will be ay double prime plus by prime plus cy is equal to 0. And basically the way that you solve these, or the way that you find the general solution, also known as the complementary solution, is you identify what the auxiliary equation is, or the characteristic equation is another name that people may call it, and then you find the roots of that auxiliary equation, and your final answer will take a certain form, and the certain form that your final answer would take will depend on the type of roots you get. So if you get real and distinct roots, your answer or your general solution should take a certain form. If you get complex roots, your general solution should take a certain form, and it's a pretty straightforward process. So I've done plenty of these types of differential equations. I've solved plenty of these, and I have so many examples on YouTube, basically second order equations, third order equations. So if you really don't know how to do it, please check out my videos on that. I don't want to spend too much time in this video talking about the whole spiel of second order equations and whatnot, because we're on a time constraint. But feel free to reach out to me or check out on YouTube. So the first thing that we need is the auxiliary equation. So let's just go ahead and get that. So remember, the auxiliary equation will just take the form AR squared plus BR plus C is equal to 0. So that means that our auxiliary equation in this particular case is just going to be R squared minus 6R plus 13 is equal to 0. So that's going to be our auxiliary equation. Okay, so now that we got the auxiliary equation out of the way, what we need to do now is find the roots. And there's two ways you can do this. The easiest way to do it is to factor and find the roots that way, or use the quadratic formula. Typically factoring is obviously the most popular way, but sometimes you may need the quadratic formula. So in this particular video, I'm going to use the quadratic formula and show you guys how to find the roots using the quadratic formula. Pretty sure I spelled quadratic wrong, so I apologize about that. But hope you remember from algebra that the quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so we need to use the quadratic formula in this case. So let's identify what a is, what b is, and what c will be. So a in this case is obviously just going to be 1, b is negative 6, and c here is going to be 13. So we just have to use the quadratic formula. Again, factoring is the easier way to do it, but we're just going to use the quadratic formula in this particular case. So what we'll have is, negative 6 plus or minus, and then we'll have negative 6 squared minus 4 multiplied by 1 multiplied by 13, and then that's all going to be divided by 2 multiplied by 1. Okay, so we know that we're just going to get 2 down here. 2 times 1 is 2. Let's take care of the discriminant. The discriminant is the square root and everything under it. So it's going to be negative 6 squared minus 4 times 1 times 13. And we see what we get here. So we're going to get 13, excuse me, we're going to get 36, excuse me, not 13. 36 minus, that's going to be 52. Because 13 times 3 is 39, so that would be 52. So we'll have 36 minus 52. That's the square root of negative 16, which is 4i. Okay. Now, I have to remind students all the time, it is true that you can't take the square root of a negative number and get a real number. But when people say that you can't take the square root of a negative number, you can. It's just that when you do it, you get a complex number. The square root of a negative number does not exist among the set of real numbers. So it's very important to remember that. So keep that in mind. So we get 4i. So now all we got to do is go through and kind of clean everything up. So this would be negative 6, and then this would be plus 4i all over 2. And then we're going to have negative 6 minus 4i all over 2. Okay, so it looks like we're obviously going to get complex roots. So we can just say that r here, if we simplify, well, it looks like we're going to get 3 plus or minus 2i. So these are obviously complex roots. So our solution, general solution, will take a certain form. So let's go ahead and finish this up. Put it right here so I can see it. Okay, so since we got complex roots, recall that our solution will take the following form. Okay, so for complex roots, it's going to be y of t is equal to c sub 1, which is c sub 1 and c sub 2 are arbitrary constants, and it's going to be e raised to the lambda t multiplied by cosine of mu t plus c2 e raised to the lambda t multiplied by sine of mu t. So that's if we get complex roots. Okay. So all we have to do is plug in the appropriate information and simplify it. So we'll go ahead and write our final answer. Okay. So our final answer, or our general solution, also known as the complementary solution in this particular case, is going to be e raised to the 3t multiplied by c sub 1 cosine of 2t plus c sub 2 sine of 2t. And that's your general solution and your final answer. Okay, so again, just let me know if you got any questions about it. I do have videos on this on my YouTube channel, so it's probably best to go check out a few more videos on that if you like. Alright, so hopefully everything made sense, and I will see you guys next time.